Hello and welcome. Today, we're going to tackle one of the most famous and, let's be real, sometimes infamous equations in all of algebra. We're going to dive right into this beast and figure out how to slay it once and for all.
And it's not just students. For a lot of us, seeing all those letters and numbers can just feel intimidating. So if you've ever felt a little lost looking at y equals mx plus b, I promise you are definitely not alone. But that's all about to change.
Because here's the big secret. This isn't some super complex monster. Really, you should think of it more like a recipe. A super simple 2-ingredient recipe that can describe literally any straight line you can possibly imagine.
So, to understand the recipe, we've got to understand the ingredients first, right? Let's break down the two most important parts of this whole thing, the m and the b.
Okay, let's start with b, the y-intercept. This one's the easy one. B is simply your beginning. It's your launch pad. If you're saving money, B is the cash you already have in your bank account before you start. If you're hopping in a taxi, it's that flat fee you pay just for opening the door. It's that fixed one-time value where your whole story begins.
And now for m, the slope. So if b is the start, m is the action. It's the change, the movement, the rate. It's not the money you already have. It's the $10 you save every single week. It's not the flat fee for the taxi. It's the cost per mile. Basically, m is the part that happens over and over and over again.
And people mix these two up all the time. It's the most common point of confusion. But just remember this. B is a one-time thing, your starting value. M is the repeating action, the rate of change. It's the difference between the start and the journey itself.
Which brings up a question I bet you've wondered about at some point. I mean, B for beginning, that kind of makes sense. But why on earth did they pick the letter M for slope?
Well, here's a fun little piece of trivia. A lot of people guess it comes from the French word monter, which means to climb. And that's a great story, but there's no real evidence for it. The truth, according to math historians, is that the choice was probably totally random. It looks like an Irish mathematician just started using it in a textbook back in the 1840s, and it just stuck.
Okay, so now that we know our ingredients, let's actually start cooking. Let's move on and see how this simple recipe builds a visual, a line on a graph.
We're going to get our hands dirty with this specific example. Y equals 3/4 x minus 3. Now, it might look a little tricky with that fraction in there, but I promise you, the process is always simple.
It's just 3 steps, every single time. First, you begin with b. That's where you plot your starting point. Second, you move with m. You use that slope like a set of directions. And third, you just connect the dots. That's it. It works every time.
So for our equation, what does that actually look like? Well, step 1, begin with b. Our b is -3, so we find -3 on that vertical y-axis and put a dot right there. Step 2, move with m. Our slope is 3/4, so from that first dot, we rise up 3 units and then we run to the right 4 units. We plot our second dot right there. And then step 3, we just draw a line connecting them, and boom, that's our line.
Oh, and a quick note here. What if the slope is negative? Super simple. Instead of rising, you just fall. A negative m just means the line is going to go downhill from left to right. So if you had a slope of, say, -2, you just go down 2 and then run to the right 1. Same process, just a different direction.
All right, we've got this. But what happens when the equation doesn't look like our nice, neat little recipe? What if it's in disguise? Let's tackle what some people think is the trickiest part of all of this.
So, sometimes you're going to see an equation that looks more like this. 3x minus 4y equals 12. This is called standard form. And as you can see, our m and our b are kind of hidden in there. But don't worry, the mission is always clear and simple. Just get y all by itself on one side of that equal sign.
And just like graphing, we can break this down into a few easy steps. First, you move that whole x term over to the other side. Second, and this is important, you divide everything by the number that's attached to y. I mean, every single piece gets divided. And finally, you just simplify and clean it all up.
So let's actually do it. For 3x minus 4y equals 12, we subtract 3x from both sides. Then, we divide every single term by -4. A negative over a negative gives us a positive, and 12 divided by -4 is -3. And look what we have. Y equals 3/4 x minus 3. That's the exact same equation we just finished graphing. We've unmasked it.
Okay, so why does any of this actually matter?
It's a totally fair question. Why is this one specific equation so important? Well, let's connect this abstract formula to the world all around us.
The really crucial thing to get here is that this equation is a fundamental tool for making predictions. A business can use it to forecast their profits based on how much they sell. A scientist could use it to model how a population changes over time. Heck, even something as simple as your phone figuring out how long its battery will last is based on this linear relationship. It's a way of turning a constant, predictable change into a glimpse of the future.
All right, so you've basically conquered the line on a flat map. You've got this. But our world isn't flat, is it? So the next logical question is, what happens when we step off the page and into the real three-dimensional world?
Now that you really understand slope on a flat piece of paper, a 2D plane, here's a final thought for you. What happens in 3D space? What's the slope of a line that's, I don't know, flying through the room you're in right now?
And the answer is, well, it's a bit of a trick question. Lines in 3 dimensions are a little more complex. They don't have just one single number for their slope. Instead, they have something called a direction vector, which describes how they're changing in the x, the y, and the z directions all at once. It's the next evolution of the exact same idea you've just mastered.
You know, when it comes right down to it, learning y equals mx plus b is a lot like learning to ride a bike. It's really wobbly at first, and you might feel like you're going to fall over. But with just a little practice, and by really understanding those basic parts, the starting point and the rate of change, you find your balance. And once you do, it becomes this amazing foundational skill that can take you anywhere. You've officially slayed the beast.